Welcome students. In this class we will discuss about problems in centrifugal pumps. Before going to the topic, we just revise what are the things we discussed in last class. First thing is efficiency. In efficiency we will have three efficiencies. First one is manometric efficiency. Manometric efficiency is nothing but manometric head divided by head given by impeller. Head given by impeller is nothing but at outlet point we will have three velocities. One is tangential velocity, then second one is relative velocity, then absolute velocity. We will have whirl velocity and flow velocity also. In this head imparted by impeller, we have, how we can calculate means that flow velocity at whirl velocity at outlet and the tangential velocity at outlet. If we multiply both things, then we divide by G, then we will get manometric efficiency. Next is mechanical efficiency. Mechanical efficiency is power at impeller divided by power at shaft. Power at impeller already we discussed in last term itself. So we just if we divide that by shaft power, then we will get mechanical efficiency. If we multiply both efficiencies, we will get overall efficiency. This is velocity triangle diagram for centrifugal pump. Point 1 is inlet, that means center of the pump. Point 2 is outlet, that is nothing but nearer to casing part. At inlet we don't have whirl velocity. At inlet whirl velocity is 0. At inlet what we have is flow velocity on Vf1. That Vf1 is nothing but equal to V1. We know what is VR1. VR1 that angle is called vane angle. Relative velocity angle is called vane angle. So at inlet we will have U1, VR1, Vf1. At outlet we will have VR2, V2, Vf2, Vw2, U2. For U1 and U2 we will have formula pi d160 n by 60, pi d2 n by 60. Then V1 and V2 are absolute velocities, VR1 and VR2 are relative velocities, Vw1 and Vw2 are whirl velocities, Vf1 and Vf2 are flow velocities. If angle made by relative velocity means that is called vane angle. If angle made by absolute velocity is called guide blade angle. This is a diagram. At outlet if you see Vf2 is nothing but Vw times tan beta or U2 minus Vw2 times tan phi. You will get this idea. Okay, these are the things we discussed in last class. Now we will go for problem. You see, a centrifugal pump delivers water against a net head of 14.5 meter. That is nothing but manometric head, and a design speed of 1000 rpm. N is given. The vanes are curved back at angle of 30 degree with the periphery. The impeller diameter is 300 mm and outer width is 50 mm. Determine the discharge of the pump if manometric efficiency is 95%. We know what is manometric efficiency. First formula is manometric efficiency is nothing but if you see we know what is manometric efficiency, G into H2 Hm divided by Vw2 into U2. Out of this we have to find U2. How we can find U2? U2 is pi d2 n by 60. How we can derive pi d2? How we can get? Here diameter is given in the problem itself. Net head is given, speed given, then they gave vane angle is given, pi at outlet given, pi equal to 30 degree. Impeller diameter means diameter of impeller at outlet only. Okay, that's important point. So diameter is also given 300 mm. Outer width B2 is given. Manometric efficiency is given. We know what is tangential velocity. Formula U2 equal to pi d2 n by 60. here manometric efficiency is given, hm given, so we have to calculate VW2. VW2 is nothing but flow velocity. If I know flow velocity by using the world velocity, VW2 is nothing but world velocity at outlet. But for finding discharge, we need flow velocity. For finding discharge, we need flow velocity. How we can calculate flow velocity means by using U2 and V2 in previous slide itself. In previous slide itself, we see flow velocity at 2 is equal to U2 minus VW2 into tan phi. If I know U2 and VW2, we can get VF2. Okay, this concept is used here. Very simple. By using that, we calculate VW2. Then by using VW2 and U2, we are getting VF2. If I know VF2, if I multiply that with peripheral area is nothing but pi d2 b2 times VF2, I will get discharge. Again, we will clearly see the problem. First one is a cylindrical pump delivers water against a net head of 14.5 meters and a design speed of 1000 rpm. The vanes are curved back at an angle of 30 degree. That is nothing but vane angle. Okay, the impeller diameter is 300 mm. So diameter of impeller is given. We don't know whether that is outer diameter or inner diameter. If simply they are given as impeller diameter, then we should consider the diameter as outer diameter only. Then and outer width is 50 mm. Determine the discharge of the pump if manometric efficiency is 95%. We know what is manometric efficiency, but manometric efficiency given, manometric efficiency is equal to GH divided by VW2 U2. Out of this, I know formula for U2. What I need is discharge. For finding discharge, I need flow velocity. For finding discharge, I need flow velocity. For flow velocity, flow velocity is not given here. So what we are doing is U2. I am using tangential velocity and finding world velocity at outlet. By using tangential velocity at outlet, I am finding using manometric efficiency formula. I will find world velocity at outlet. By using world velocity at outlet and tangential velocity at outlet, I will find flow velocity at outlet. If I know what is flow velocity at outlet, then I will get discharge. This is a simple concept. This is the first problem. Mostly out of I here used 3 problems for getting clear in concepts. If we know these 3 problems, surely we will get any one problem in exam. Then the internal and external diameter of impeller of centrifugal pump are 200 mm and 400 mm respectively. If this internal and external diameter given, then I have to calculate U1 and U2. That means tangential velocity at 1 and tangential velocity at 2. Pi d1 n by 60, pi d2 n by 60. N also given 1200 rpm. Vane angle of impeller at inlet and outlet are 20, 30 respectively. So at inlet, vane angle given. At outlet also vane angle given 30 degree. We know what is vane angle. Vane angle is nothing but relative velocity angle with respect to horizontal direction. Relative velocity angle with respect to horizontal direction. The water enters the impeller radially and velocity of flow is constant. Velocity of flow is they given as constant. Determine the work done by impeller per unit of water. What I have to do is, first thing is diameter given, 2 diameters given. So I have to calculate 2 tangential velocities. U1 is equal to pi d1 n by 60, pi d2 n by 60. Here diameter is given in mm, but for in problems we will use same units. So instead of mm, I am using as meter, and I am calculating U1 and U2. Then from inlet velocity triangle, what given is vane angle is given. So I know what is vane angle. By using that vane angle, by using U1, just see inlet velocity diagram. This is inlet velocity diagram. By using vane angle theta and u1, what is tan theta? Tan theta is equal to Vf1 divided by u1. By using that formula, what I am getting is tan theta equal to Vf1 by u1. I know what is u1, I will get Vf1. Since they mentioned as in the problem, they mentioned as velocity of flow is constant. That means Vf is constant. So Vf1 and Vf2 both are same. So Vf2 also I calculated. Just simply I am taking Vf1 is equal to Vf2. So Vf2 is equal to 4.57 meter per second. From outlet velocity triangle, I can calculate tan phi. Tan pi is equal to Vf2. I know what is Vf2. By using Vf2, I can calculate what is Vr2. That is what they did. From we know tan phi on outlet velocity, tan phi equal to Vf2 divided by u2 minus Vw2. By using that, I know Vw2 is nothing but 17.215 meter per second. Just to go through this video by pausing the video, then you will get a clear idea. Then what is work done by implies 1 by g into Vw2 into u2. I know what is u2. I don't know Vw2. For calculating Vw2 only, I did these steps. Instead of finding Vw2 directly, I calculated Vf2. For Vf2, I used Vf1. By calculating Vf1, I went to Vf2. By using Vf2, I calculated Vw2. By using Vw2 and u2, I calculated work done by impeller. Okay. This is second problem. This is also important problem. Out of 3, we discussed about 2 problems. Remaining problems are we have one more problem. Out of these 3 problems, we will get at least one problem in exam if problems are asked. Else, you will get theory questions. This is third problem. It's a very little big problem. A centrifugal pump is running at 1000 rpm. Outlet vane angle is 45 degree. So with respect to relative velocity, if I see pi is given 45 degree. Velocity of flow at outlet is 2.5 meter per second. So Vf2 is given 2.5 meter per second. Discharge through the pump is 200 liters per second. I know 200 liters is nothing but 0.2 meter cube per second. I have to convert that. Then when the pump is working against a total head of 20 meter, if manometric efficiency of pump is 80%, then determine diameter of the impeller, the width of the impeller at outlet. Very simple. We know what is manometric efficiency. Okay, first in this velocity triangle diagram, see what are the things we know. First I know what is n. Then outlet vane angle is given. Then flow velocity at outlet also given. Flow velocity at outlet is 2.5 meter per second. And outlet vane angle also given. By using pi and Vf2, then I calculate what is Vw2 and u2. Okay, for that what I am doing is they did same thing. They considered outlet velocity triangle. Tan pi is equal to Vf2 divided by u2 minus Vw2. In this I know what is Vf2. Yeah, Vf2 தெரியும், but I don't know what is Vw2 and u2. So Vw2 is equal to u2 minus 2.5. Then I know what is manometric efficiency formula, 0.8 times GH divided by Vw2 u2. In this I know what is Vw2. I don't know Vw2. So I am substituting Vw2 is equal to u2 minus 2.5. Then in this formula I calculate Vw2 u2 is equal to 245.25. Then I am substituting Vw2 from equation 1 in equation 2. For example, here Vw2 equal to u2 minus 2.5. Vw2 in equation 2, Vw2 u2 is 245.25. So instead of Vw2 I am substituting as u2 minus 2.5. then everything becomes in terms of u2. Then we simplifying that quadratic equation, then I'll get u2. If I resubstitute this u2 in either equation 1 or equation 2, I'll get vw2. Okay, so u2 is given. Then how I can calculate u2? I know u2 is equal to pi d2 n by 60. By using that, I can calculate d2. For discharge, I know formula pi d2 b2 vf2. Vf2 also I calculate given. Only thing not given is b2. D2 is in last step only we found d2. If we substitute everything, we will get b2 in meter. We convert that into millimeter. These three problems are, in my point of view, for last 4 or 5 semester questions, mostly repeated. So because of that only, I took these three problems. And also you have to work with previous semester question papers, which will be helpful for you to score good marks, and you will get some practice problems in those things. So hope you understood the problems. Just try to solve. I used problems from R.K. Bansal book. That is a good book in point of understanding concepts and preparing for university exams also. So kindly refer that book for problems. Here I mentioned problem numbers also in that book. If you see, you will get a better idea. If you see, if you understand these three problems, that will be enough for solving centrifugal pump problems. Okay, thank you for listening. In next classes, I think that may be last class. In that class, we will discuss about various curves which are drawn for a centrifugal pump and specific speed. What is meant by specific speed, and the different curves, characteristics curves for pumps. Up to that, we will finish fourth unit. It's just a basic introduction class only. By using this class and by referring textbooks and solving previous year question papers, you will get a better idea in understanding the problems. Okay, thank you.